Now let's look at the Laplace transform of a trigonometric function, let's say cos 2t in this case. So you just punch in cos 2t into the definition of a Laplace transform and introduce the limits. Then now what you see here is a product of two functions, and you just need to do your integration by parts. And of course, I gave you some hint here. This is the Liet logarithmic inverse trigonometric functions, the algebraic, the trigonometric, and of course the exponential. This is guiding you the choice of the u. So of course the trigonometric functions come before the exponential function. So our proper choice is u is equals cos t, then du is minus 2 sine 2t dt, and then dv is now e to the power minus st times dt. Then v is just the integral. The integral of the left-hand side is the integral of the right-hand side. Then v becomes minus 1 over s e to the power minus st. So from there, now we use that formula for integration by parts with our limits affecting everything. So this will be uv, so that's minus 1 over s e to the power minus st times cos 2t, evaluated from 0 to t, and then minus 2 over s. So it's minus 2 times minus 1 over s times sine t e to the power st dt. So that becomes minus 2 over s times sine 2t e to the power minus st. So now we have this integral is not vanishing. So we okay, try and let's try and basically evaluate this component here and leave this as is. So if we evaluate this component t, we'll get this guy here, and then of course minus the evaluation at t is equal to 0, which gives you 1 here, 1 here, and over s, so plus 1 over s. And this one will go to 0, provided s is greater than 0. At some point, we will learn that this function cos 2t is actually of exponential order. And if it is of exponential order, then this limit here goes to 0. We will see that at some point. Okay, but convince yourself that this limit goes to 0. You have done the limits before. So then here we have minus 2 times the limit as t approaches infinity of 0 to t of this. So we need to do another round of integration by parts, choosing our u as sine 2t, and our du now becomes 2 cos 2t dt, and dv as usual, we chose the same here, and we will know what it is here. So now we have this 1 over s, we leave it there, minus 2 times the limit as t approaches infinity of now, applying the integration by parts method here, we then have uv minus e to the power minus st over s sine 2t evaluated from 0 to t, plus now 2 over s again, 2 over s times the integral from 0 to t of e to the power minus st times cos 2t. So now we have gone back to the original cos 2t, so which means we might replace that integral by just the Laplace of cos 2t at some point. So this is what we have, and then this one it goes to 0 again by the same reasoning that I gave above. And of course, when you go to, if you evaluated 0, then everything becomes 0. So it will be this whole component will go to 0. So then we are left with the 2 minus 2 over s times 2 over s, which is minus 4 over s squared, times the limit as t approaches infinity 0 to t of this integrand here. So we allow t to assume its extreme value, then it will just be from 0 to infinity and drop the limit. Then we have exactly what we have here. And if we look at this particular integral here, if you look at this, you basically, if you look at this integral here, you definitely see that is the same as this, what we defined here at the beginning. So I will replace this right-hand side by just the left-hand side. So from here, I can just come and replace this by Laplace transform. So what do I have? My equation, remember, it started here. This is the left-hand side. And what I have here is the right-hand side. So I can rewrite it and say the left-hand side was the Laplace transform of cos 2t is equals to the right-hand side. So now I can see the Laplace transform is common on both ends. And then from there, it's okay, because I have, let me highlight it here and highlight it here. I have common terms on both sides, so I can bring this one to the left-hand side and factorize, then I get 1 here, and then this is minus 4 over a squared. That becomes 1 plus 4 over a squared times the Laplace transform is equals to 1 over s. And of course, I need to make sure that I still maintain the condition that ensures convergence or existence of the Laplace transform for cos 2t. So from there, I play with the algebra and make the Laplace transform, substitute the formula, and what I get is now something that is nice here.